seen a magnet with this shape before. It's called a bar magnet. It looks like a chocolate bar. What happens if we bring it near an iron nail? We know that as we bring it closer to the nail, at some point the nail moves towards the magnet and sticks to it. Moreover, it remains there until we manually separate it from the magnet. So why does an iron nail stick to the magnet? This is because of the force of attraction that binds the magnet and the nail together. This force is applied by the magnet on the nail and hence it's called a magnetic force. Here is one interesting question that I want you to answer. Is magnetic force a contact force? In other words, is the contact between a magnet and the nail necessary for the magnet to attract the nail? Let's look at the animation in slow motion. We are moving the magnet towards the nail. And at this point, the nail also begins to move towards the magnet. It means the force came into action even when there was no contact between the magnet and the nail. Hence, we can say that a magnetic force is not a contact force. Contact is not necessary for the magnetic force to work on the nail. To understand this better, we bring this magnet close to the nail and move it slightly up in the air. You will find a slight movement in the iron nail as well. This means that the iron nail is under the influence of a magnetic force even though it's not in contact with the magnet. It again proves that a magnetic force is not a contact force. So we can say that it's a non-contact force. The force exists even though the magnet is not in contact with the iron. But what does this non-contact nature of the magnetic force tell us? It tells us that there is an invisible field produced by the magnet in the space around it. And if you bring any ferromagnetic material in this field, then it experiences that force of attraction. We cannot see this field, but it exists. This field is produced by a magnet and hence it's called a magnetic field. Now I'll ask you an interesting question. Do you think the strength of this field is even throughout the area around the magnet? Let me explain this to you with a relatable example. Assume that there is a working Wi-Fi router present at some location. It gives off signals in all the directions in some range. Now, in order to connect a mobile phone to the internet, we need to bring it in this range only. This signal will be stronger nearer the router. The closer you bring your cell phone to the router, the stronger the signal will be. One can think of magnets in the same way. A magnet has a magnetic field around it. The strength of this field is greater closer to the magnet and decreases as we go further away from it. As you bring any ferromagnetic object in this field, it experiences a magnetic force. The closer we bring that object to the magnet, the greater the force it will experience until at some point where the force will be large enough to make the object leap towards the magnet.